Ellwood Quality Steels Company is a market leader, supplying high-quality, low-cost clean steel ingots to the open die forging, ring rolling, and extrusion industries. EQS is known for flexibility and responsiveness, seeking to give our customers a competitive advantage in their markets. Located in Newcastle, Pennsylvania, our steelmaking process begins with the receiving of recycled steel, often using more than 85% of these inputs for EQS products. EQS accepts this material only after it is scanned for radioactivity using specially designed Geiger counters. Additionally, there are radiation checks prior to the scrap entering the mill, before scrap material is charged, and on a chemistry sample taken at the end of the primary melting process. Scrap is also tested for chemistry compliance using a handheld X-ray fluorescence testing device. If accepted, the scrap is unloaded and separated into bins according to the alloy content, density, and size. These bins are conveniently located inside the mill, which protects them from the adverse weather conditions. Our melters use a computer model to optimize the scrap charge for each of the various grades and heat sizes made at EQS. Once a charge is designed to our customer specifications, scrap is loaded into the electric arc furnace. This ultra-high-powered furnace employs a twin hydraulic lance injection system to blow oxygen and carbon into the furnace. This injection system, combined with 3 separate oxy-fuel burners, achieves fast, efficient melting. Phosphorus, an impurity, is removed from the steel bath by refining it into the foamy slag as oxide, which is continuously flushed from the furnace. In less than an hour, the molten steel is ready for tapping into the refining ladle via eccentric bottom tapping, or EBT. The entire furnace is tilted as the steel is tapped into the ladle along with a specific amount of alloys and deoxidizing agents, calculated from our computer model. A reducing top slag is also automatically added when tapping is complete. The ladle is then transferred to the ladle refining station. Here at the ladle refining station, the alloy calculation program consistently brings the chemistry to the aims supplied by our customers, utilizing our state-of-the-art Level 2 computer system. The alloy additions are automatically weighed and transferred from bins into a hopper and then charged into the ladle. To ensure chemical and temperature uniformity, the process requires induction stirring. Induction stirring mixes the steel beneath the slag cover using magnetic forces. In addition to helping create a uniform bath, the induction stirring also aids in the removal of non-metallic inclusions by creating opportunities for them to be absorbed into the reducing slag. Next, the ladle is transferred for vacuum degassing. The liquid steel is covered by the degasser hood, which is sealed onto the ladle. The pressure is lowered to near vacuum conditions, which facilitates hydrogen escaping from the steel. For effective hydrogen removal, a very high stirring energy is achieved by a combination of argon bubbling and induction stirring. This action is maintained through the entire degassing cycle. Hydrogen samples are taken and analyzed after degassing to help ensure that the hydrogen levels are within EQS standards. A final test for certification is also taken from liquid steel in the ingot molds at the end of teaming. Once degassing is complete, the steel is transferred to ladle furnace number 2, where it may be treated via calcium or sulfur wire injection. These alloy additions can improve either the mechanical properties or the machinability of our steel, depending on our customer's application. At ladle furnace number 2, the steel may be reheated and final alloy adjustments made before the liquid steel is teamed from the refining ladle into the ingot molds. The teaming temperature is controlled to within 5 degrees Celsius. A precisely controlled teaming temperature is critical to producing high-quality forging ingots. In the teaming bay, dry clean molds are set up for each specific heat. The ladle is centered over the trumpet and the slide gate is open. As part of our continuing effort to produce high-quality clean steel, argon shrouding is used to help protect the liquid steel stream from reoxidation and hydrogen pickup during the teaming process. All ingots produced are bottom poured at a controlled rate, with all information monitored and captured using the Level 2 computer system for maximum consistency. EQS maintains a large variety of mold shapes and sizes in order to accommodate the various ingot requirements of our customers. After solidification, the molds are stripped. Each ingot is tagged with identifying information for tracking purposes. Molds are cleaned after use using a flaler, which removes buildup and debris inside the mold to ensure optimum ingot surface quality. This process, along with periodic grinding of the inner mold walls, enhances the surface quality of future ingots. Car bottom furnaces are available for slow cooling and specifically designed annealing cycles for each grade, enabling us to supply stress relief ingots with uniform hardness. After every ingot is thoroughly inspected, they are either shipped hot or slow cooled. Hot shipments have been made as far as 200 miles away and help our customers save on reheating costs. For ingots that are cooled, EQS has the capability to surface condition, flame cut, or saw cut to meet customer requirements. In addition, the chemical composition of all cold ship material is checked using a positive material identification test prior to leaving the mill. EQS delivers ingots by truck, rail, or sea, both domestically and outside the U.S. The EQS quality control system has been certified to ISO 9001 and AS 9100 internationally recognized quality standards. This system was implemented using a highly trained workforce and utilizes state-of-the-art equipment, including an in-plant chemistry lab that is certified to ISO 17025 and a metallurgical testing lab that includes a scanning electron microscope, complete with EDS elemental analysis capability. As an industry leader, EQS takes pride in knowing that our steel is utilized in a wide range of critical applications. That is why we are continuously striving to improve both our process and our products. With a focused effort on providing high-quality material and maintaining a competitive advantage, EQS and its employees are committed to exceeding our customers' expectations by being focused on your success.